Thank you for the presentation slide. Yes, welcome to the weather briefing. My name is Andreas Wirth from Central Institute of Meteorology in Vienna, Austria. And normally you hear me later, but this time I'm going to present the synoptic situation of the day. So we inverted the roles a little bit, and Yasmin comes later with a case study of a very interesting Föhn storm we experienced recently in Austria. So let me start the actual weather briefing. I think this is the typical satellite image you expect from me. When we are in autumn, it's the high resolution visible image. And what you can see here are lots of low clouds and not so many high clouds, no fronts. That's the typical autumnal high pressure, nice weather if the sun comes through weather situation. So let's start with annotating the low clouds in this image. I think this is not too difficult for you. So take the pencil and make contour lines through around the low cloud patches you can identify here. Yes, that's fine, but there are a lot more. Sometimes it's a bit doubtful if there are. Yes, exactly. We have them over the Atlantic, over the southern part of the British Island, in the eastern, exactly, that's nice, Central Europe, and here also over northern Italy. The characteristic of these low clouds is quite simple. It's very low and smooth and not so bright and clear than the high ice clouds, because they are mainly water clouds, not all of them, but mainly water clouds. If they have more structure, like here, for example, over, I would like to annotate that. Does not work because you have. Okay, here it is. I hope you can see my pointer. Here over northern Italy, the cloud tops are a bit more structured, so it's difficult to say if it's low clouds only or if it's a bit higher. But in general, you're right. That's what you can identify immediately when you see this image. The next image is a zoom. Because I identified a very interesting structure over Bavaria. So, I mean, this here, I hope you see my pointer. You see these curls, these stripes, and this is quite interesting. Obviously, there are some plains in the lower regions of the troposphere, but not within the low clouds, just above. Here, on the eastern part, you see also some lighter stripes. These are probably plains on higher altitudes, leaving contrails. And in the beginning, I was not sure if the planes, when they land, and obviously they do land here because they make such circles, if they do not dissipate the low cloudiness in a given region or track. But this is certainly not the case, because if you have a look at the loop, you see that this moves in the direction from the east to the west. So this pattern here is moving and is not stationary, while the low clouds are stationary. They are not moving. So it's a clear sign that this comes from higher clouds, from contrails, which throw their shadows on this low clouds. But low clouds is certainly a topic. Here in this very high resolution, you can see the clouds entering the valleys, while the center of the Alps, where it's less humidity, the valleys are free from fog. So this is the typical situation seen in the infrared image. You see there are not so many high clouds, but there are obviously some low clouds. But the infrared image here from 0 UTC from midnight last night is certainly not the best choice to discern low clouds. If you have a close look, yes, you can discern lower clouds, but it's really hard and not so easy. Therefore, there are other means we are going to see soon. So as I told you, this is the typical situation, autumn situation. We have a high pressure area over Central Europe. Air is descending. The low clouds are formed mostly during the night and are sometimes dissipating in the morning, but not always. So this is the mean sea level pressure, and in the higher levels you see this typical omega situation. So you have this. I will take a pencil now and try to draw it. We have this omega situation. It looks like an omega, maybe not perfect, but with a little bit of inspiration, you can see the omega shape of this in the 500 hectopascal height of the geopotential. So the clouds are mainly over the Atlantic or over Russia and in the east, and in the center it's mainly cloud-free. There's some higher clouds, but nothing special, no fronts, and this is a typical situation for the omega situation. So let's have a look also at the temperatures last night. So they should not be very high because it's in the night, but still they are quite warm. And we have this region here going up to the north. You see even here north of Petersburg 2 degrees, which is quite high. And here also up this whole ridge is filled with temperatures at midnight, plus degrees, even sometimes 7 degrees. In the center we have 4 degrees of Europe, so quite unusual warm. And this situation prevailed since quite a few days now, and we had a very nice and warm October. We had a very nice and warm November. The cold air, I changed the color, the cold air can be seen here over Russia. We have the reservoir of very cold air, which still did not come to Europe and did not lower the temperatures. But still see here the temperatures are normal for the time of the year, -8 degrees, which is -13, which is quite cold already, but normal for mid-November. But in Central Europe and Western Europe, we have warm temperatures on the ground. Yes. So let's go further. Now again, there are two different kind of. You have already identified the low clouds here, for example, here over the east, but also here, and you see clearly that they have different colors. Here in this region, we have some kind of greenish, whitish color, while here it is already a little bit more into the yellow and red. Also here we have red and yellowish colors. By the way, here we see bare ground. Maybe the color is not so good. Red on red is not so good. We have bare ground and reddish color, which shows no clouds but very cold surface, as I indicated in the previous slide. So the question is now, why are there two different colors for the low clouds? We have here the color. I take my pointer again. We have here the color rather greenish, and here rather yellowish. Do you have any idea why the low clouds have different colors? And you can write it in the chat box. So what is your idea why these colors are different? Both represent low clouds, stratus clouds. Exactly. Someone asked, why is it low clouds, different colors? Why is that? What do you think? Any idea? No? So, if you don't have an idea, maybe the next slide will help you. This is the cloud top height. The cloud top height from the nowcasting subproduct, and you see here that there's no convective activity involved in these low clouds. It's stable, stratified. there is no instability in this region. But what you can see here clearly is that these clouds over Western Europe, which were greenish, whitish, are water clouds, purely water clouds with a temperature a little bit above 0, 2 degrees. And if they turn a little bit more yellowish, you see that they are mixed phase clouds. They are higher, they are colder, they contain ice crystals, but they are still low clouds, still low stratus clouds. And we have here an average temperature of -10 degrees, so much colder. And you can compare the color here with the legend. The dark red or brown is about 2 degrees, you see it here, and if it's going to the orange values, it's the cloud top height. I'm mixing it. I'm confused. The clouds are higher, also not only colder but also higher, and are mixed phase clouds. And here you see they are about 2,000 meters, 2 kilometers is the height in this northern region, Poland and the Baltic states. So these clouds in the southwest are much lower, only water clouds, and in the northeast they are higher and consist of mixed phase clouds, ice crystals and water droplets, both. And that reflects in the RGB in the different colors. So let's continue. Let's shift a little bit to the Atlantic, and I would like you to, now we have also fronts, of course, because they are produced over the Atlantic, and normally they are drifting eastwards and come over Europe, but now we have this omega situation, they are not coming to Europe. Can you indicate the occlusions, and with the occlusions the low pressure areas? So it's quite easy, I think. Yes, the occlusions. I see 3 of them. Yes, fine. That's quite clear. So I would say this is an occlusion, very clear. This is an occlusion, and this is an occlusion here in the north of Scandinavia. Let me erase a little bit your annotations. What is that here? It looks like an occlusion, this here, but we call it differently. Has anyone an idea? It's separated from the cold front. It's just in the trough region. Yes, it's a comma cloud. Very good. So it looks a little bit like an occlusion, but it's not related to the fronts. By the way, this nice occlusion here I'm contouring is a cold conveyor belt occlusion. Why? Because the cold conveyor belt I like to draw it now in green. The cold conveyor belt is coming from here, below the warm front. Here's the warm front, and it's below the warm front, turning to the north, moving to the north, and you see here the height difference in the clouds. We have high clouds from the front, from the cold front and the warm front, and then from below you see the relative stream moving to the north, and this one is called cold conveyor belt, and that's why we call it cold conveyor belt occlusion. So fine, thank you for your participation. I'd like to finish the current analysis of the satellite image with a vertical cross-section. I think they are very, very interesting. I made one vertical cross-section through the cold front, which is waiting over the Atlantic to be able to penetrate to Europe. It looks very nice. You see clearly here on the right-hand side the front in green. Maybe I should draw a thicker line. If it's, yeah, here's the front. You see the warm air here in front over Europe, and the colder air here, because it's the temperature which is plotted in red and blue, the colder air behind over the Atlantic. So you see clearly the difference of temperature, the warm air over Europe and the cold air over the Atlantic. Let's have a look into the future. What will happen? So I told you already the situation has prevailed for quite a long time in this way. What you see here is the mean sea level pressure, so this the pressure at surface, and this typical omega situation here in the height 500 hectopascal height. So this is from tonight, 0 UTC. I made bigger steps of 2 days to see how this situation transforms, because once such an omega situation is in place, it's quite stable and does not change so quickly. So what happens? The surface high pressure moves to the north, you see it here, and the omega is a little bit deformed. You see here colder air from Russia penetrating to Central Europe. Then 2 days later, Monday, midnight, what happened? The high pressure moved to the north. So Central Europe is now on the margin between high and low surface pressure, and the omega situation has disappeared. We have here the colder air which penetrated from Russia. I told you there's a reservoir of cold air which slowly moves down to Central Europe. And the same here can be seen for the 2 meter temperature and the 30 meters wind. We see again today in the night, we see here still warm temperatures over Central Europe. 2 days later, we see that this wedge of colder air here comes to Europe, and this is still present here on Monday morning. So the temperature gradually gets colder, and it's the end of the nice warm autumn weather. We will have to get used to the colder winter weather. So much for the current weather. And I cannot finish my presentation without talking about the California wildfires, which are currently ongoing, and they reached another maximum. So the wildfires, I'm sure you have heard of that in the news, because they are in every news, and you have seen the reports and read it in the papers maybe. In fact, the wildfires in California started already in April, and there were 65 larger wildfires until November this year. And here is a list I have from Wikipedia, because this webpage is quite up to date. Here you have the last ones from October to November, and the really big ones here happened in November. And you have seen maybe or heard maybe that they are given names. The very big one, which started on 8 November, is called the Camp wildfire, and there's another one, the Woolsey wildfire. But the Camp wildfire is one of the most severe and intense wildfires, which killed a lot of people, and many buildings have been destroyed. It's one of the most severe wildfires California experienced since the 30s. Yeah, I have some nice images, nice under apostrophe, of course, but the satellite images take this situation. This is taken from the EUMeTrain page, and you see here an image from the Allsea imager. Yes, good comment in the chat. There was, on one side, there was a drought. There was not a lot of precipitation the whole summer, so this increased the drought, and the vegetation suffered a lot, and it's very dry. On the other side, there is strong winds at the moment, which fueled even more the fires. So these two effects led to the strong development of the wildfires we experience at the moment in California. So this is from the Allsea imager. The Allsea imager is called the Ocean and Land Color Instrument, and we have here the RGB, the true color RGB. That means that's the colors we see with the eye, and that's what is very easy to interpret for us, because these are the natural colors. The Allsea instrument, by the way, is focusing on very short microwave channels, so from 0.4, I do not know it by heart, but I have written it here, from 0.4 to 1.02 micrometer. So mainly the visible images. And it's on Sentinel-3. And we have here another image from the Landsat Landsat imager, and you see here nice fires. It's combined with shortwave infrared. You see here the fire front, and you see the burning areas in red, which is the same campfire, called campfire, which was devastating a lot of houses and injured people. So, and I have, I think, a last image of the Woolsey Fire, which still is a very intense fire, but not that strong than the camp wildfire. And here I found very again not nice for the people living there, but it's a nice to see how it looks like if you are there from the ground and from the satellite imagery. So thank you from my side. This was a short view at the California wildfires, and I hand over now to Yasmin. And please, Yasmin, the floor is yours.
Thank you very much, Andreas. I hope everybody can hear me. Thanks for the very interesting talk. So we have heard winter is coming. Before that, we will just go back a bit in time. I will share my screen now. All right. So we'll jump back a bit in time to the end of October, where we had this interesting case about interesting weather feature I will talk about now. My name is Yasmin Markl. I work at ZAMG as well, like Andreas, and yeah, I sit here in my office in Salzburg. So let's have a look. I would like to start with this loop of geopotential and temperature at 500 hectopascals. So what you can see here is this very well-pronounced trough over Spain that moves to the east. And I have also made this small sketch here of the Alps. And you can already think about what I would like to discuss now in the next couple of minutes. Andreas actually has already said it, but if you don't remember, just think about what kind of weather feature could it be that's very interesting here, especially here in the Alps. All right, I think it's maybe obvious, maybe not, but what's interesting here is, heavy rain. That's a very interesting point. It's not what I'm going to talk about, or not only, let's say that. What was very interesting here, at least at the northern side of the Alps, was the Föhn wind. So let's see. Yeah, it was a Föhn wind, and for this Föhn wind we had two important prerequisites, so to speak. It was the obstacle, namely the Alps, the Alpine ridge, and the strong southerly flow that comes with this ridge. If we go on and also add the wind arrows here at the same height, we can again see that wind is very strong, at least forecasted very strong, and the wind blows parallel to these isolines. So if we go, for example, if we see some of those time steps, we see that there are unusual high wind speeds. We also see, and maybe that's something we can see here in the first time steps best, this cold air that is lying in this trough and that also moves towards the Alps. That will be of interest then later if we have a closer look. So we have said that we have the southerly flow and we have the obstacle, but what else is very important for Föhn winds? Do you have any idea? Just take some kind of marker or anything and click on something that you think could enhance the Föhn wind even more if we have it, or could have a very important impact on Föhn winds. Again, use your mouse and go to the top of the screen where this little window will open, and then you can click on annotate. So, right, okay. I think I have to approve then. Right, Okay. Okay. So, okay, so we have, okay, some interesting, good. Thank you, yes. Yes, very interesting. So we have many people that say the temperature difference is important. We have people that say the pressure gradient, also humidity. We have the chance of precipitation. So there are many factors that play a role indeed. The most important things, however, is actually the pressure gradient and a temperature difference between the north and the south. So let's stop annotating and okay, sorry, 1 second. Annotation tools, right. So the pressure gradient. Why is the pressure gradient important? If there is higher pressure in the south and lower pressure in the north of the Alps, of course we have the pressure gradient force, and that would then enhance the wind speed. Of course, it would amplify the Föhn wind. And on the other side, the temperature difference plays a role because there's colder temperature. Also, the local static pressure increases, and therefore, again, we have this increase in the speed, or in the triggers of Föhn. Okay, we will now see if we find those two factors in our case from end of October. So I would like to play this loop again, and maybe you look at the cold front, what is happening here. So now let's play it again, and maybe stop it somewhere here. So this is actually quite unusual, because at this time the cold front did not approach from northwest, as it very often does, but in this way it came from more or less southwest, and I have tried to sketch it here. So the cold air mass really first approaches the southern parts of the Alps, and here we have exactly this situation, that the colder air is in the south, and relatively warmer air than is still in the north, and we have this factor that was very important here. Let's also have a look at the pressure gradient. These are time steps from Monday evening till Tuesday noon. So let's say over the night from Monday till Tuesday, this is low sea level pressure, and you can see the small arrows that are 10 meter wind arrows. You can see that the pressure, I'm trying to get this annotating to. Okay, I hope it works. You can see that this low pressure system here at the ground overnight moves to the north, and then eventually is here somewhere north of Germany. Okay, stop annotating. It's complicated. So it moves overnight from the south of the Alps to the north. That means that in the morning of Tuesday, okay, you can see my mouse, that's very handy. In the morning of Tuesday, eventually the low pressure is in the north of the Alps, like you can see it, for example, here, and then relatively higher pressure would be in the south, or was in the south. Okay. In terms of wind speeds, if we look at the forecasts, at this time it was still the forecast, we had wind speeds up to over 190 kilometers per hour, so quite remarkable. And now I would like to jump from this forecasting to the nowcasting, so to speak, to monitoring, and for this I have prepared this loop of the 24 hours microphysics RTB. I would like to play it now and just watch and enjoy. So many different things to see. I have been chosen the 24 hours microphysics because this goes overnight, and then we have the complete picture of Monday and Tuesday. Well, I will go to the start again, play it once more. So here, east of the Adriatic Sea, we can see very nice leeway or lee cloudiness here, very nice structures. And if we go on in time, what's also interesting is that we will see the low pressure system that's here moving to the north in the overnight, and then if we stop here, we can see that there we have this cold front that comes in and crosses the Alps. There's something else that was a very important factor also at this weather situation. We have heard it before. I will start again from the beginning. Is there anything else, especially if you think about the southern regions of the Alps, that jumps into your mind, might play a role in this situation? Let me stop maybe here. Anything, if you look at those thick clouds here. Yeah, thunderstorms. We did indeed have also thunderstorms, just a few, but yes, that's true. What I think what was more important and had much more effect was just very much rainfall in these areas over a couple of days. And if we go on, here's a summary of how much rain we had, and that was flooding, and yeah, up to over 400 millimeters within a couple of days. While in the north it was all dry and kind of just stormy. So this was very remarkable. Now let's jump back again to the Föhn wind. One thing I wanted to show you is this effect of the cold air that's coming in. So here we have one station where Föhn just started when this front approached. So we see this very typical spread of temperature and humidity. We see here the increase of wind speeds of the gusts, of course, and we also see that the direction of the wind is at this station it's more difficult, but this here is south, so it's more or less south compared to other days when it was all kind of different directions. Another station that is more to the east shows pretty much the same thing. So we have this very strong spread between temperature and humidity, so the air gets very dry. We have a very strong increase in the wind gusts, and we have here this wind speeds from southern direction. Okay, then there was something else that I was actually experiencing on my way to work. Here in Salzburg, I have made a star here on this satellite image, so that you know the position of this station. And this is Salzburg Airport. What I'm talking about is that there we had two maxima in wind speeds or wind gusts. So how is that? The first, obviously, was with this cold air approaching. So that was the first one. But the second one, how did it happen? I tried to find out. So the second one would be here. And I had a look at a local model for surface pressure at the time when the second maxima was there, and I saw that here we have this small, tiny low pressure system here north of the Alps. And this is exactly what I was talking before. So because of this low, very small low pressure system here, a second time the wind speeds increased a lot, and also if we add now the wind fields, we can see that yes, exactly. This probably was the reason why the second maxima appeared. It moved quite quickly from, I don't know, somewhere southwest to northeast, so it was just a short time, but had very high impact also at the city. Yeah, a roof was blown away from our castle, and was a big deal. Okay, so this is just the chart where you can see some maximum speeds that we were measuring in Austria, so up to 170 kilometers per hour. Yeah, maybe even more where we did not measure. And just a quick look at the time. Okay, we're almost finished. This is just to show you this very nice line here, where again you can see that the clouds were quite dense in the south, and actually very, yeah, like almost clear skies, at least in the beginning here in the north of the Alps. And a second animation here of fog RGB, because it has a very good resolution, shows you some nice lee waves in eastern Austria. So most of you, I guess, know it. Lee waves on the lee side of mountains, especially if there's strong flow. All right, and also some webcam images here that show a similar or the same effect over different time steps. We see that this cloud band here is not moving. Good. This is my last slide. I would like to finish, and thank you very much for listening, for joining, for enjoying. And yeah, if there are questions left, or if you want to discuss a bit more, just stay with us. And yeah, announcement for the next weather briefing. It will be on December 18th at 13 UTC, and it will be held by the German Weather Service. Okay, thank you very much.